Hi everyone, and welcome back to Fundamentals of Engineering with Farhad, Mechanics of Materials, Angle of Twist Phi in Torsion. This time, if we consider like our previous problem, which is a tapered cone, last time we reviewed this problem with a concentrated load of P at the top here, and this time we are just applying a torsional torque of T at the very top, and we want to calculate the angle of twist at A. So that's phi sub A. To approach such problem, we need to jump to a torsion formula, and also the diameters and radius of bottom and top are provided, like C at the beginning and 2C at the end with the length of L. So we have like torque shaft with variable cross section. So in such case, again, if we just flip our problem like 90 degrees and then consider our uh, differential element somewhere at the middle, then we jot down the equation of phi, which is the integration for variable cross sections, integration from 0 to L, which is from the beginning to the length of L of a tapered cone, then T dx over Gj, with G stand for shear modulus and J stand for polar moment of inertia of our section, which is a circle. So again, if we just make it like extended to the origin of O, that we have like a complete entire a cone, then we have like LA equal to L, LB equal to 2L, because the information for the length is provided. So if the total length of our tapered cone is L, the height is provided in problem statement, then it simply says we need the same length to reach to O with the same slope, and LB is 2L from the origin O. And then we just need to jot down and differential a equation for our element in the middle, which is traveling from the beginning of our tapered cone to the end, from dA to dB. So dx is traveling along the sample, and make the integration of the whole tapered cone to give us the phi A, because the other end is fixed. So LA over LB is equal to DA over DB, and that's how you can see here LA to LB is equal to, related to their diameters. Then the same story applies for DX. DX over DA is X, which is the location of our differential element from the origin, and DX is equal to XDA over LA. And also, if you want to have the area, you can just simply plug in the dx in the area equation. A sub x is equal to pi d squared over 4. So that's how you can get also ax. But we in our problem, we just need to know what dx is. As soon as we know this part, we have the differential form of our element, which travels along A to B to give us the phi angle of twist at A. So again, phi or angle of twist is integration in a variable cross section, in our case from 0 to L or from L to 2L, T dx over Jxg. So in our case, it's just from L to 2L. It's from L, which is our origin is here. LA is equal to L, and L sub V is equal to 2L. Then in numerator T dx over G times J. We know what our limits of integrations are. We already calculated our elementary form of differential form of our dx, which is x dA over LA, and J is polar moment of inertia of a section, and that's for a solid circular shape is a half of pi radius to the 4. And if you convert it to diameter, it just gives you 1 over 32 times pi times d to the 4th. And definitely Jx, which stands for our differential element, that's 1 over 32 times pi times dx to the 4. Simply replace our equation for dx to equation of jx, and you will get this equation: 1 over 32 pi in parentheses x dA over LA close parentheses to the 4th. You have like your polar moment of inertia for x section. And then phi a is integration of L to 2L of t dx over gjx. And if you simplify, again, we have like integration here. Don't forget to have your integration from L to 2L over here. But the only thing you can easily pay attention is the other are constant came out from the integration, and the only part which goes through the integration is dx over x to the 4th in the integration. So if we took out the constant out of integration, and then we are left with integration of dx over x to the 4 over L to 2L, which is the length of our tapered cone considering the origin O. Then if you replace it and make the integration of dx over x4 is equal to negative 1/3 of x cubed from L to 2L. If you do the math, it just gives you 7 over 24. Make the math and make the simplification. It just gives you 7 over 24 L cubed. And if you plug it in phi a equation, it just gives us, and cancel out what you can cancel, it just gives us phi a is equal to 7 over 12 t a L over pi g c to the 4th, which is c is the radius of here, and this is like, this part is 2c based off problem statement. Then if you have the problem statement once more, which we have like we're looking for phi sub a due to a torsional torque at the top, then phi a is 7 over 12 TL pi times gc to the 4th. Thank you. We'll solve more problems in torsion.